In this lesson, we're going to talk about a third type of asymptote called a slant or oblique asymptote. So up to this point, we've dealt with two other asymptotes, the vertical and the horizontal asymptote. We know that when the degree of the numerator is larger than the degree of the denominator, that there is no horizontal asymptote. Okay, when that happens and the degree of the numerator is exactly 1 degree higher than the degree of the denominator, there is a slant or oblique asymptote. So if we look at this example that we have here, we can see that the degree in the numerator is a 2, and then the degree in the denominator, right, there's really like a little 1 here, is a 1. Now, since the degree is larger in the top, we know that the horizontal asymptote would be none. And the degree in the top here is exactly 1 more than the degree in the denominator. So that means that there's going to be a slant or oblique asymptote. Okay, and looking at the graph, we can see that there is no horizontal asymptote. There's no dotted line that's going horizontally. We do see this blue dotted line, that's our vertical asymptote. This function cannot be simplified, so we know that to find the vertical asymptote, we can take the denominator, 3x plus 2, and set it equal to 0. If we solve this, 3x equals negative 2, x equals negative 2/3. And that's the vertical asymptote that we see here in blue. That's x equals negative 2/3. But then we see this red dotted line. And so dotted line indicates it's an asymptote. And notice that it is not vertical or horizontal, right? It is slanted or diagonal. So that's called our slant or oblique asymptote. So in order to find the equation of a slant or oblique asymptote, we need to use division. Okay, so the oblique asymptote or the slant asymptote is going to be a linear function. So it's going to be a line that's a diagonal line. And to find this, we're just going to divide the numerator by the denominator. Now, when we learned about division with polynomials, we learned that there's two different types of division. There's long division and synthetic division. Now, there are times when you can use synthetic, and then there are times when you cannot use synthetic. Okay, so just kind of like a refresher. If you're dividing by a linear function, meaning the exponent is 1, okay, then you can use synthetic. I would recommend using synthetic only if the leading coefficient is also a 1. So looking at this example, we do have a linear on the bottom. The leading coefficient is not a 1. Okay, so I'm actually going to use long division here. So we're going to take the denominator and put it on the outside, so 2x minus 4. And then we're going to take the numerator and put it on the inside. Now remember, we do need to have placeholders in place. So if we're missing any term, we have to put in a 0. And we can see here that we go from x squared to a constant of negative 9. We're missing that x term in the middle. So we're going to put x squared plus 0x minus 9. When we're doing long division, we're looking at the first of each terms. So 2x is the first of what's outside, x squared is the first of what's inside. So we have a 2x and we want it to become an x squared. So if you can't think about 2x times what gives you x squared, you can just take the number that's inside, so for instance x squared, and divide it by what's outside, so 2x. So if I take x squared and I divide it by 2x, that's going to simplify to give me x over 2, which is the same thing as saying 1/2 x. So I'm going to go ahead and put 1/2 x on top of the other x terms. So you want to make sure that we are stacking the same degree. Once you have your number at the top here, we're going to take it and we're going to distribute it to both terms on the side. So I'm actually just going to get rid of this line so we don't get confused. Okay, so I'm going to distribute the 1/2 x times the 2x, which is going to give me x squared. 1/2 x times negative 4 is going to give me negative 2x. Okay, I'm going to go ahead and subtract, and I am going to put it in parentheses so I don't forget to distribute that negative sign. X squared minus x squared will cancel. 0x minus a negative 2x becomes positive 2x. We have two terms on the outside and only one term on the bottom, so we do need to bring down that next term in order to have the same number of terms. And again, just to make this look nicer, I'm just going to get rid of these little arrows. And now we just repeat the process. So we take the first term on the outside and the first term on the bottom. You have a 2x, you want it to become a 2x. So what times 2x gives you 2x? That's going to be plus 1. Okay? If you want to also set it up like we did over here, you can just take what's on the bottom, which is 2x, and divide it by what's on the outside, which is 2x. Right? This will reduce to 1. That's where we get that 1 from. And again, we're going to take that 1 and we're going to distribute it to both terms that are on the outside. So we have the 1 times the 2x, so that's going to give us 2x. 1 times negative 4 is negative 4, and again, I'm going to subtract using parentheses. 2x minus 2x will cancel out. Negative 9 minus a negative 4 is going to be positive negative 5, sorry. That's our remainder. So when we're doing our slant asymptotes, we don't care about the remainder. We just want to chop off the remainder. So we only care about the part that's up here after we divide it. So this, it could have a remainder of 0. It could have a remainder of a number. It could be an expression. We're just going to ignore the remainder. So that means that our slant asymptote is going to be written as a diagonal line. So we're going to do y equals, and we're only going to look at what's on the top. Okay, so y equals 1/2 x plus 1. So this is our slant asymptote. So in this class, all we're going to do is find the slant asymptote and then maybe just graph the actual line. We're not going to graph the full rational function that has a oblique or slant asymptote. You'll be doing that in pre-calculus, but it's very similar to what we've been doing to this point. All right, so if I wanted to graph the asymptote, it's just a line. So I'm going to go to the y-intercept, which is 1, put a dot at 1. My slope is 1/2, so I'm going to go up 1 over 2, up 1 over 2, up 1 over 2, whatever, and then down 1 over 2, down 1 over 2, down 1 over 2. And because it's an asymptote, we're going to have it dotted, so I'm just going to follow this line that I drew, and this would be how I would draw my slant asymptote if I was going to draw it with this rational function. All right, so let's look at this next example. So in this example, I would use synthetic division because of the denominator being a linear with a leading coefficient of 1. Okay, if you like to use long division instead, you can just use long division as well. If we're going to do synthetic, which I just wanted to review again now, we're going to take what's in the denominator. So I'm going to make this purple. Take what's in the denominator, which is x minus 5, and we're going to set it equal to 0. So x equals 5. That's going to be the number that goes outside of our division. And then we're going to take the coefficients of the top and put them in order here. We're not missing any terms, so we don't need any placeholders. We're just going to have a 3, a negative 10, and a negative 25. That's a pretty crooked line we have here. Let's see if I can fix that. So with the synthetic division, okay, we're going to take the first term and just bring it straight down. Then we're going to multiply 3 times 5, so we get 15. We're going to add these together, so negative 10 plus 15 gives us 5. 5 times 5 is going to give us 25. Negative 25 plus 25, we're going to add this, we get 0, and this is our remainder. So this one happens to go in evenly. Okay? It doesn't necessarily have to, because again, we're just ignoring that remainder. So here, our slant asymptote is going to be y equals, and then we drop a degree. So we started with x squared. So this is now going to be x, so 3x plus 5. So this is our slant asymptote, or if you want to write it as OA for oblique asymptote, that's also fine. And again, let's just graph this. So we have a y-intercept of 5, and then we have a slope of 3. So that means that we're going up 3, 1, 2, 3, and over 1. Same thing in the other direction, down 3, 1, 2, 3, over 1, 1, 2, 3, over 1. And then I'm just going to fill this in, oops, as a dotted line that's pretended straight. Okay, so let's do another one. Now here, because we don't have a linear in the denominator, it is a quadratic, we cannot use synthetic. So in the first two examples, we could have used synthetic because of it being a linear function in the denominator. But here, when it's not a linear, you have to use long division. So let's set this up. So practice doing long division. So we're going to take the denominator. We're not missing any terms in the denominator, so we're just going to write them. 3x squared minus 6x minus 9. And then in the top, we're missing, so we have x cubed. We're missing x squared, so 0x squared. We have an x term, so minus 9x. And then we're missing our constant term, so plus 0. Okay, so again, we're going to look at the first terms only. So if we look here and here, all right, I have a 3x squared and I want it to become an x cubed. Okay, if you're not sure, take the x cubed, divide it by the 3x squared. This would simplify to x over 3, oops, which is just 1/3 x. Okay, so I'm going to put that above the other x term so that we have them all lined up. And then we're going to take the term that we have on the top and we're going to distribute it to everything on the side. So I'm going to go ahead and distribute. It's getting distributed to the 3x squared. So 1/3 x times 3x squared is going to give us x cubed. 1/3 x times negative 6x is going to give us negative 2x squared. 1/3 x times negative 9 is going to give us negative 3x. Okay, and then we subtract, again using parentheses to make sure we distribute that negative. So x cubed minus x cubed cancels out. 0x squared minus a negative 2x squared is a positive 2x squared. Negative 9x minus a negative 3x, that becomes negative 9x plus 3x, so negative 6x. And then we have 3 terms on the outside, so we need 3 on the bottom, so we're going to bring down that 0. Okay, so again, look at the first terms, 3x squared and 2x squared. So if you're not sure, set it up, 2x squared over 3x squared. The x squareds will cancel out, and we're left with just 2/3. So here's going to be plus 2/3. That's supposed to be a 3 if you can't see. And then again, oops, that's supposed to be an eraser. All right, so now we're going to take that 2/3 and we're going to distribute it to everything that we have on the outside. So 2/3 times 3x squared is going to give us 2x squared. 2/3 times negative 6x is going to give us negative 4x. 2/3 times negative 9 is going to give us negative 6. And really at this point, we don't really care what comes next because we have everything at the top filled in. We can subtract this and distribute the negative. So this would become negative 6 plus 4x, which is negative 2x. 0 plus 6, so 6. This is our remainder. And again, we don't really care about our remainders here. So we're just going to look at what we have at the top. And that is going to be our slant asymptote. So we'll go ahead and write that in. Slant asymptote is y equals, and this is going to be 1/3 x plus 2/3. Okay, and again, if I wanted to graph that, I would just go to 2/3 as my y-intercept, and then a slope of 1/3. So that means I'm going up 1 and over 3. 1, 2, 3. Up 1, 1, 2, over 3. I'm going to go down 1 and over 3. 1, 2, 3. Down 1, 1, 2, 3. And again, fill that in with a dotted, line. All right, we're going to do one more. This one's a little bit longer. Okay, looks bad. Same process. Okay, all of these examples have a top degree or a degree in the numerator that is 1 more than the bottom. Now, if the top degree was more than 1 away from the bottom, it would not have a slant asymptote. It would just not have a horizontal. It would not have a slant. But in all of these cases, the difference between the numerators, the numerator and denominator degrees are just 1. So these all do have slant asymptotes. So always double check before you do these problems. Don't assume that if the top's bigger than the bottom that it has a slant. Make sure it's exactly 1 different. So here, we're going to set this up. So I'm going to do x cubed plus 3x squared plus 3x plus 1. Okay, it was not missing any terms, so I didn't need any placeholders. Here we have negative 3x to the 4th plus 4x cubed plus 6x squared plus 4x plus 2. Again, not missing any terms, so I don't need any placeholders. Okay, again, I'm using long division because my denominator is not a linear function. And we're going to look at the first terms. We have x cubed and negative 3x to the fourth. Okay, we have this, we want this, so what times x cubed is going to give us negative 3x to the fourth. Again, if you need to set it up, take negative 3x to the fourth and divide it by x cubed. So here we're going to end up with negative 3x. So I'm going to line that up with the other x term. So negative 3x goes here. I'm just going to get rid of this. So now again, we're going to take what's at the top and we're going to distribute it to the terms on the side. So negative 3x times x cubed is going to give us negative 3x to the fourth. Negative 3x times 3x squared is going to give us negative 9x cubed. Negative 3x times 3x is going to give us negative 9x squared. Negative 3x times 1 is going to give us negative 3x. And again, subtract using parentheses so we don't forget to distribute the negative. Negative 3x to the fourth minus a negative 3x to the fourth, that will cancel out. 4x cubed minus a negative 9x cubed, so we're adding this. That becomes a 13x cubed. 6x squared minus a negative 9x squared, that's going to become 15x squared. 4x minus negative 3x, that's going to become 7x. There's 4 terms on the outside, there's 3 terms on the bottom, so we're going to bring down that last term so they have the same number of terms. And again, we're going to look at the first terms. So we have x cubed and then 13x cubed. So we have an x cubed, we want a 13x cubed, so we need a 13. Okay, and then again, we will distribute. So 13x, we're going to distribute to the 4 terms we have on the outside. So this is going to give us 13x cubed. Then we're doing 13 times 3x squared. So that's going to be 39x squared. And then 13 times 3x is going to give us 39x. And then 13 times 1 gives us 13. And again, subtract in parentheses so we distribute that negative. 13x minus 13x cancels. 15x squared minus 39x squared. We get negative 24x squared. 7x minus 39x is going to give us negative 32x. And then 2 minus 13 is going to give us negative 11. Now this is our remainder. Again, we don't really care about it, so I know we just did that extra work for it. But as long as we filled in this top here, we know we're good. So slant asymptote would be y equals negative 3x plus 13. And again, if I'm trying to graph this, I have a y-intercept of 13, so we'll just put that like here. Slope was negative 3, so we're going to go down 3 over 1, down 3 over 1, down 3 over 1, and I'm just going to fill in poorly, oops, pretend that that looks good, what this kind of would look like.